Lesson 63, Symbols of Inclusion. Okay, here are the symbols of inclusion. We have parentheses, and I know how to spell it because I always think of parent Hesses. I don't know why, but parent Hesses. Parentheses. Then we have brackets, and we have braces. So we need to know the names of these. I've been trying to use them as we go. Absolute value. I just start at the top, do a little curve, pull a little, I don't know. Mine don't even look very good. Absolute value are those two bars, you know, that mean the distance away from 0. One thing you have to know here is you want to do all the math inside and then take the absolute value. Okay, so if you see absolute value symbols, you want to do all the math inside before you take the absolute value. Now, another symbol of inclusion is the fraction bar. So we have 1, 2, 3, 4, 5 different symbols of inclusion.
Do the brackets and the braces mess with the order of operations?
I will show you how.
How come they're different kinds?
I'll show you why. I'm super excited about these questions. Okay, so you want to do the work here. So you want to get to just one number here, and then you want to get to one number here. So you just have one number divided by another number. Then in your order of operations, when you get to division, you're going to divide those two. So when you have problems that you have symbols of inclusion inside symbols of inclusion that are inside more symbols of inclusion, we always start the furthest most inside with parentheses. And then if we have more work to do, then we do brackets. And then if there's more inside there, and we do braces. Then we start over with parentheses, brackets, braces. So we've had problems that look like this. I'm just going to make up one real quick. You don't have to write it in your notes, okay? So you could have like 2 plus 3, and then you have 6 minus, and then here you have plus 25 and square root of 64 plus that or something, and that's braces, okay?
And then you do the whole thing.
Yeah, and then you have to do like maybe 100 minus, and then take the absolute value.
Whoa.
Anyway, when absolute values are just wherever they put those, but these 3 types of parentheses or symbols of inclusion, we go in order. So we're going to go inside, the very furthest most inside, do all the work in there, and you have to do the order of operations inside this. So if in here was not 2 plus 3, but was 2 plus 3 times 5, you still have to do order of operations. You got to times first, then add, and then you have a 17 there, and then you do 6 minus that, and then when you get your answer there, then you would add all those.
8.
Okay, so
Let's do it.
sometimes they ask you to justify your work. Oh wait, I was going to put this with nested symbols. Do you guys know what that means?
No.
That means symbols of inclusion inside symbols of inclusion inside symbols of inclusion, like the one I just showed you. They're nested inside each other.
What if you just do like, it's supposed to be parentheses, but you use brackets instead? That would make sense.
It would not make sense to me, but that's just because I'm a mathematician and I know how it should be. So We always use braces when we're talking about sets. So you know how sometimes you write the, what's it called when you're doing probability and you want the sample space?
Yeah.
That's it. When you do sample space, we always use braces for that because that's a set. When you're doing problems, we always, the very first time you want to do a symbol of inclusion is parentheses, and then if there's more, you do brackets, and then braces, and then parentheses, brackets, braces. We just keep repeating that one.
Is this like the baby version of college homework?
Yes, it is. So with nested symbols, you do the most inside one first. Okay, so just like on that example I showed you, you'll go and do those parentheses first. Yes.
I remember nested symbols like nesting dolls because they're
Oh, yeah.
inside one another.
Like nesting dolls, yeah, so they're inside one another. Excellent. So sometimes they ask us to justify our steps. We've had to do a couple of that this year with properties. So when they give us a problem, we actually put that as a step. So this is going to be an example. So we're going to say, okay, that was what was given. So then we know we have to do the most inside symbol of inclusion first. We're going to do this parentheses. So we have 50 minus, once you do the parentheses, you can change the brackets to parentheses. Now this is just convention. If you don't change them, I'm not going to mark it wrong. But I would do 20 plus 15. And that simplified within parentheses. Then you simplify these again. 20 plus 15 is 35. Now you don't need the parentheses anymore. And you would use the same reason. Simplified within parentheses. Okay. Yeah, they have all the brackets and stuff in yours. Just put it in those brackets. And then 50 minus 35 is 15. And the justification is subtraction. So you just subtracted these two. And you could just put that down because that's what you did. So that's the end of the lesson. We're going to do some practice.